Hello, everyone. Welcome. The event is starting now, so if you could please grab your seats so we can kickstart together. Thank you. Okay. One more minute. Okay, it started. One more minute and we will start. Thank you. Yes. Yes. Thank you. Just gonna give you a few more minutes. Okay, great. Hello, everyone, and welcome to the final event of the Innovation Challenge for Green Digital by Hitachi, powered by Agorize. We are very happy to have you here today, startups, judges, mentors, offline or online. So before we start, just wanted to present myself. So I'm Ryan. I will be your host today. Very happy to be here. And so today, just to give you an overview of our event, we will start with opening remarks. Then we will have our judges present themselves and then go over the challenge, what the startups, mentors went through to get here today. And then we will quickly remind the pitching rules and then kickstart the pitches for today. After the pitching session, we will have a jury deliberation time during which startups and mentors can mingle here and have fun. And then we will have the award ceremony and closing remarks. So to kickstart this event, I am pleased to present Mr. Kiyoshi Kumagai to give our opening remarks.
Thank you. Good morning, everyone. Thank you for joining us here in London for the final event. My name is Kiyoshi Kumagai. I'm a senior manager, corporate venturing office, Hitachi Limited. First of all, I'd like to express my gratitude to all the startups that participated in this challenge event. Over the past 5 months, we have been truly inspired by your passion and innovation challenges. Also, I'd like to extend a deep appreciation to Agorize and Hitachi Vantara office management members. Without your support, this precious opportunity would not have been possible. Today, we are gathered here with the 10 finalist startups. Your ideas and technologies hold a lot of potential to shape our future. We eagerly look forward to the presentations and to knowing your visions. At Hitachi Group, our mission is to contribute to society through innovation. So collaborating with startups is a crucial step towards achieving our goal. The topics presenting today, data center and digitalization of energy and railway, are very important for us. So we sincerely hope to create new value together with you and build a sustainable future. In closing, I hope today's event will be meaningful for all of you, providing opportunities for new partnerships and inspiration. Now, please enjoy today's presentation. Thank you.
Thank you so much for this introduction. Now I would like to ask our fellow judges to present themselves quickly, like a 30-second, 1 minute maximum presentation of who you are before we start with our pitching session. So I would like to start with.
Thank you. Good morning. Nice to meet all of you. It's really a pleasure to be here. I'm Fabrizio Landini. I'm the global head of the data center segment in global marketing sales of Hitachi. I've been working in the data center segment since 2009, so more than 15 years. The segment, the IT segment, the data center segment is very dynamic. So I'm really happy to see, we have to look at innovation and the new ideas coming from a company like these startups is very valuable and important for the segment. So I'm really pleased to be here to listen at this innovation, these ideas, and contribute with the startups and with the Hitachi Group to the future of the segment. Thank you very much.
If we can pass to
Hello, good morning, everybody. I'm Jim Bruin, Chief Director for Hitachi Rail in the UK. I've worked for Hitachi now for over 17 years in the rail group, and I'm incredibly excited today to see what the startups can bring in terms of innovation. So huge congratulations for making it this far, and we're really looking forward to your presentations. I think from a rail group perspective, green and digital is fundamental to our future strategy and everything we want to achieve as a collective business, both locally here in the UK, and we're delighted you're here in London, but more broadly in terms of our wider ambitions across the globe to digitalize our operations internally, but also focus externally with what we can offer our client base. So we really look forward to the presentations, and a pleasure to meet you all. Thank you.
So good morning, everyone. So I'm André Burdet. I'm based in Switzerland. So right now I'm heading the Environment Business Division for MEA region. So in this division, it's a corporate function. We look at innovation all across the board for all our businesses. So I'm very glad to be here. A long time ago, I created a startup and I failed miserably. So I know the feeling. But after I actually pivoted to some other activities, and today I can say I'm quite happy. So we can fail, but after we can win also over the long term. So I'm very, very happy to see all those startups here, also contributing for Hitachi, for the industry also that we are in, and I look forward. Thank you.
Hi, everyone. I'm Vitor Domingos, based here in London. I'm from Hitachi Digital Services. I'm the lead solution architect and a Gen AI evangelist, if you may. I've been working with customers to deliver the best solutions that we can do with them. And I'm just saying that because you said you had a startup, I have a bit more success than you. I sold my startup a few years ago, so got rid of that. I work in the corporate now. So hope and looking forward to see all of you presenting your ideas later. Thank you.
Good morning, everyone. My name is Yuki Sugimura. I'm a general manager of the European R&D Center and also chief technology officer to Hitachi Europe Limited. So European R&D is one of the larger Hitachi R&D groups, and European R&D focusing on the kind of a digitalized railway and the wider sustainability topics like biodiversity and so on, and of course, digital solutions. And also we extended our research portfolio to disruptive technology development like quantum computing. So that's our research portfolio. So today I'm here as an R&D representative. So I'm just looking for hearing some innovative ideas from startups, and congratulations for passing through the qualifications, and looking forward to hearing from you. Thank you.
Okay, good morning, everyone. My name is Kenichi Funaki. I'm based in Tokyo. I'm a head of corporate venturing activities across the Hitachi Group. The Hitachi launched the current CVC work in 2019, and we are running 3 funds with a total size of 600 million US dollar currently. But today, in addition to the investment side, we are really excited to hear about the potential opportunity to co-work with together. And the congratulations on being the finalists, and look forward to hearing a lot of things from you and learn together, and then design the future together. Thank you very much.
Thank you. Thank you so much. Now, before we start, I just wanted to go back to the program and what all our startups and applicants went through to be here today, because it is a very big achievement for our 10 finalists. So to go back, we launched the application phase of this challenge in September, and we gathered more than 200 solutions. Then we had a first selection phase, selecting the top 40, who went through a mentoring phase, which led us to this final event here with the top 10 solutions. So today we're here to select the top 3. So wishing everyone very good luck. Our solutions were presented across 4 main categories presented by Hitachi, mainly energy optimization and management in data centers. We also had solutions in digital battery circulation with data utilization, enhancing manufacturing and energy efficiency in energy asset production, and finally, railway operation efficiency with digital tool data collection. So for each startup, we will remind the category they presented in so that you can have this reference in mind. What's I think the most important and interesting here is everything that our startups will have access to uh, thanks to this program by Hitachi. So in addition to pitching here today to top executives from Hitachi, startups will have the opportunity to collaborate with incubation representatives. They will also have the opportunity to discuss proof of concepts to implement with Hitachi, and of course connections to business units. So everything is positive. Everyone is a winner here today. And well, congrats to everyone. So next. So before we start, just reminding everyone of the main rules that we will follow for the pitching session. Each startup will be called either offline or online to pitch. They will have 5 minutes to pitch their solution. We unfortunately have to be a bit strict, so we will have to cut you when we reach the 5 minutes. You, for the startups who are offline, you will have a timer here in real time showing you the number of minutes left. And you will also have a more maybe straightforward sign saying, giving you this information. When you finish pitching, we will have a 1-minute remark from your mentor presenting an extra perspective of your solution before we start a 7-minute Q&A session with our jury members who are here. For our online startups, same rules. It's just that you will have one of our colleagues from Agorize online giving you information about the timing left. Does anyone have any questions, or we're good to go? Great. So for the judges, a reminder of the judging criteria and for the startups. So you will be mainly judged on the value of the issues you are addressing, your potential to create a strong customer base, the innovativeness of your technology and business model, the feasibility, and of course, the impact. So now that we've gone through the rules again, just putting here the running order that we will follow today. So the startups in black are the ones who are participating online, and the other startups are present here today with us. So this is your running order, but no worries, we will call you by your name so that you know when it's your time to pitch. Okay, so we can begin now with our first startup. So let me invite Strong Compute, who are presenting online, to please unmute yourselves and then go ahead. As a reminder for our online startup, so you can just give us the sign so that we can go on the next slide so that we can help you with this. So good luck.
Thank you. Great to be here with you. All right, next slide. I'd like to begin today by shocking you a little bit. You actually already have the solution to data center power within Hitachi, and it's storage. Yes, Hitachi Vantara is better than a battery. Let's see how this works. So imagine we're in Tokyo and we've just built a new 100 megawatt data center. That's enough power for 200,000 homes or about 100,000 GPUs. And this data center is full. We've done really well and it's running critical workloads. But it's just gone evening. It's peak power time and the wind is down. The regulator needs power and they have to make a decision. So who's going to pay the price? Is our new data center with 100% uptime going to take the fall? Are we going to cut power to 200,000 local homes? Or are we going to fire up a gas peaker plant so there's enough power, but the environment can pay the cost? So the real answer is that none of these are acceptable. And that's why we can't build any more data centers until we've built more power plants. But we have a better way, because this is not an ordinary data center. Next slide. This is a zero peak load data center, and it's only made possible by technology that Hitachi and Strong Compute have. This data center goes dark when the grid is stressed, but the work will get done anyway. Next slide. Using Vantara, Strong Compute can save workloads continuously. And using Hitachi Energy data, Strong Compute knows which data centers should be running. Next slide. Strong Compute is the glue that brings together Vantara and Energy. We've built AI compute orchestration that allows jobs to move anywhere, anytime. What you might not know is that 50% of GPUs globally are idle, and that's a high statistic from people who are running data centers really efficiently. So there's a huge amount of available GPU around the world. And many data centers built today already have some green power. And what we're now able to do is save workloads and move them and resume them extremely quickly to a data center that has capacity and has green power available. Next slide. We've achieved 3 breakthroughs to make this possible. First, we're the only system that knows the exact cost of compute that AI workloads take to run, and we can add carbon costing into this with data from Hitachi Energy. Secondly, we're the only truly multi-cloud AI platform. We can launch the same workload on 4 different clouds with 0 code changes at cluster scale. And third, we have the fastest global movement technology. We can move at 60 gigabytes a second between clouds with no hardware added at all. It's purely software. Next slide. So far, we've built the core of AI job management, global cost data into jobs, and multi-cloud capability for AI workloads. And we're here to work with Hitachi on energy and storage. Next slide. We've already enabled hundreds of engineers to run thousands of jobs, and we're working with a lot of AI R&D research centers. Next slide. From our focus on R&D labs, we want to move together with Hitachi into the enterprise from next year. Next slide. We've got a strong team. We've worked on companies, built companies worth 300 million and helped many other people build companies of that scale before and hired thousands of engineers. Next slide. We've raised 8 million from some great investors and we're expanding in market now. Next slide. Let's work together and deliver zero peak load data centers and enable zero carbon workloads. Thank you.
Thank you. Yes. We now have a small word from your mentor, Patricia Krundich.
Hi. So just a disclaimer, I thought it was a great presentation and I did not instruct the startup to tell this story. This is a story that they actually arrived at themselves. And I highlight this because it's a story that really should resonate with us because it's linking some of our different business units, including our energy, our Hitachi Vantara, into actually a platform that is focused on sustainability as well. So they have a very strong sustainability focus as well on this. It will save quite a lot of energy, but it's also impacting society because, as we know, data centers are maybe not the most community friendly companies that are currently being built. And we know that from the research that we've done that there's quite a lot of resistance. This is a very strong team. Had some great conversations with Ben. Also, investors backing this company are really impressive. So that's just a few things that I wanted to highlight after this presentation. Thanks.
Thank you. So we will now kickstart the 7-minute Q&A session. So judges,
Well, thank you very much for the nice presentation, Ben. My question is about the flavor of your customer basis or customer pipeline potentially. Could you give us a kind of example to some extent possible, the real use cases or customer cases or potential future customer pipelines?
Yeah, so our platform is presently best suited to AI development workloads. So this is model training and AI research. There are the research labs that are in our pipeline. We have around 50 of them, have a demand for around 10,000 GPUs in total between them. And in enterprise, the demand is much greater. You would see obviously the the new clusters from XAI with 100,000 GPUs just in one cluster. So we see a huge opportunity here. Across the market, the cost of GPU is only a fraction of what it's retailed for. When you rent a GPU from a hyperscaler, it's around $8 an hour for a current generation GPU. $2 of that goes to the GPU, and $6 is the actual management system. So we see an opportunity at least the scale of NVIDIA here and beyond. And this orchestration problem is absolutely massive. It's the bane of the existence of people building and developing an AI.
Okay, so you have already captured some customers in the AI labs area, and then you're on the way to expand the customer footprint to the enterprise side, right?
Yeah, that's correct. We've discussed with a few folks who are already, in that Fortune 2000 group, some major financial institutions, and some folks in the trading space, and yeah, in a few other motion pictures industry as well.
Okay, got it. Thanks.
thank you. Yes.
Thank you, Ben, for the presentation. Just a simple question. Do you think in the future, any data center operator of a decent size will be able to run their data center without your solution?
I think that it will be very challenging to get approval for new data centers unless you're building a power plant at the same time. And I think that is a massive cost and a huge complexity for many reasons. And it's going to be significantly easier to build with our technology. The approvals will come much faster. And yeah, you won't need to bring a power plant with you.
So just to follow up on this, so in that case, would you expect a very high amount of competition in your field? And who could be the competition?
Yeah, we've seen a lot of people who compete with various components of our solution. I think the challenge is how do you bring together orchestration, cost management, fast data movement? We replace about 5 products that exist and about 5 products that don't. And what I mean by that, these products are built in-house. Like the financial controls around GPUs just simply do not exist in a multi-cloud fashion at all. And so most people build something bespoke in-house and then try to integrate these 5 other pieces together. This is something that's taken us 3 years to build, and we're a startup that's purely obsessed on this. And I'm sure you can imagine the time that would take in another organization where they have other areas of focus. So we think we've got a significant head start to bring this platform out.
Thank you. We have time for one last question.
Well, I have kind of almost two. The first one is how you deal with compliance and data sovereignty because you're moving workloads between different centers. And the second one is how do you see the green coding? Because a lot of developers, a lot of companies are already investing into that. Is that a competition from your side of the market?
Sure. So to address the compliance, we're currently going through the process for SOC 2, ISO 27001, HIPAA, and GDPR. We're also working with some of our clients who have additional security certifications that have been put out by the RAND Corporation that link in with NIST. We've been going through those processes for over a year, and we're quite advanced in those tracks. When it comes to where data is allowed to be, those compliances rarely are geographically prescriptive, maybe in the most sort of stringent national security context. But something like HIPAA, medical data in the US, there's no geo restriction on where that's allowed to be processed, which might surprise you, but I've been over this with the people many times. It's true. As long as you comply with the encryption standards, it's allowed to be wherever it needs to be. Even GDPR data, there's 20 countries on the pre-approved list outside of Europe that are allowed to process it, such as Canada and New Zealand, and further countries, not the US, but several other countries are actually able to comply with GDPR as well. So there's quite a lot of latitude with where workloads can go. There are people who like to, for their own reasons, still restrict things to a single geographic area, but even within one geography, there's a lot of different data centers, many of which can be idle. With regarding to the green code approach, I think what we're doing is quite synergistic there. There's many ways to actually make workloads more efficient from a programmatic perspective, but they're always going to need some power, and you want them running in a place where that power is the greenest, even if they are efficiently developed.
Thank you, Ben. Do we have any last questions? We still have 50 seconds. Just a quick one.
Thank you, Ben, for your nice presentation. So quick question is about the coverage of the region. So I just understand your solution kind of a share and shift the workload across multiple data center, but what is the size of the coverage? So it's a regional coverage. So could you give us?
Sure. So currently, we've integrated with 4 hyperscalers, well, 3 hyperscalers and 1 neocloud. Between those providers, we have 100 regions supported. 100 regions in their parlance, which doesn't actually mean 100 countries, but it's globally distributed. We have facilities that we can access, and we do access in Europe, North America, Australia, Japan, Singapore.
Thank you, Ben. Sorry, time is up. But thank you very much. Thank you.
Thank you.
Yeah, give it a try. So now calling the second startup, Luffy.ai, to take the stage.
Good morning. I'm Daniel from Luffy AI. So sustainability is a very interesting topic because the world is inefficient. More than half the world's energy goes into manufacturing plants, and at least 10% of that is wasted. McKinsey says it's a $20 billion industry just to optimize plants every year. Now, the reason plants are inefficient is the controls that control them face tremendous variation. And control systems don't like that. They like to be stable. But they're facing variation from the environment, weather conditions, things like sensor drift, noise, mechanical wear and tear. And this causes the suboptimal performance. The good thing is that there are new technologies that are emerging. So the control systems of today, PLCs, DCS drives, were invented in the 1970s. They've come forward in leaps and bounds and advanced tremendously. But now artificial intelligence has reached the point where it's able to help with real-time industrial control, unleashing new productivity. And the value that we see that AI delivers is that it's just so much more powerful. PID, for example, the backbone of control, degrades when it's outside of its region of tuning, and only works in linear applications, whereas AI works in linear, nonlinear, and can handle many inputs and outputs. So we've created adaptive intelligence, which is an artificial intelligence-based platform very specifically designed for industrial control applications. And what we do is we start with a digital twin of the process. We then train the artificial intelligence into the digital twin and make sure that it can adapt and respond to the dynamics and transients that the control systems will face. We test this in a simulation environment, and then we deploy into real time. Now, adaptive intelligence has many secrets. One of them is that it's based on genetic algorithms. So we train neuroplasticity into the neural network, which ends up with a very light and simple architecture, which you see on the bottom left, compared to deep learning alternatives, which are very thick and heavy in structure, very formal, and are generally oversized for the control problem. So we've benchmarked our performance against deep reinforcement learning using the Google Real World Suite. So you can see that what we've done here in our benchmark is on the bottom left, just one statistic. For the same problem, Google, using DeepRL, used 145,000 synapses, whereas we only used 148, which means in this graph on the bottom right, so far we see ourselves as the most compute efficient AI on the planet. An example of what this unlocks is we've been able to get AI into standard off-the-shelf controllers. So this is a PLC. It's running at 900 microsecond scan time, and the AI only took 800 bytes, which means we could deploy hundreds of AI controllers just inside one off-the-shelf control system. Our early adopting customers are in thermal control, temperature applications, as well as industrial motor control and robotics, which lends itself very much towards applications in Hitachi's transformer manufacturing business. But we see a broader play with Hitachi. Not only can we help with transformer manufacturing, within your PLC and drive product ranges, we could help with intelligent AI functions. We could help you with clever algorithms in hydro and wind farm optimization, and then we could help your large machines work more efficiently. In transformer manufacturing, things like temperature control, level control, in casting, in vapor phase drying are very key for us. We see torque control in coil winding applications, something that we'd love to try as well. We see over $100 million of opportunity selling with Hitachi, to Hitachi, and for Hitachi in various applications. Our company is based just outside of Oxford. We're just over 20 employees, and we actually now have 11 PhDs, a team of physicists, engineers, data scientists, and mathematicians. Thank you very much.
Thank you. Yes. So now we'll have a small introduction presentation by your mentor, Francisco Penayo. So if you could please go ahead, the floor is yours.
Thank you. Francisco Penayo. I'm from HITACHI in Sweden. Sorry I can't be in London and participate. But I would like to say it's been a real pleasure to learn about LAFI. And I would like to add two things also that has impressed me on the LAFI solution, especially for increasing our capacity or also use in operations and services, is the less reliance on the cloud. Because it has a faster computation. And also another point that we at the production capacity increase have seen is implementing AI, how say the retraining of the models. So I really can see LAFI can support us in increasing our production capacity and solve also other topics for Hitachi. Thank you very much. And also, well, like I say, it's an impressive team LAFI has with a lot of experience. So it's been a real pleasure to get to know them.
Thank you. We will now kickstart the Q&A session. Do we have a first question? Yes.
So thank you for the presentation. Very deep technical, very advanced. Looks very interesting. One question I have is, how do you manage scalability with your solution if you have a large manufacturing plant with many equipments? Because you seems to go quite deep into having a digital twin as a prerequisite to run your solution. So what if you have many equipments and everything goes in different loads? How does it work? How much effort do you need to do?
Yeah, so there's many answers to your question. It's a very deep question. A digital twin for us doesn't need to be very complex. The most simplest digital twin we have is actually just two physics equations. And then the neuroplasticity and genetic algorithms cover any gaps that you get from a low fidelity model. So we can also make high fidelity models of equipment that perhaps is very high value, and that if you optimize it to the highest degree, it's going to be extremely valuable for the business. The amount of time that it takes to do one of those smaller projects versus one of the high fidelity projects is a difference probably of weeks. So a digital twin with 2 or 3 equations takes a couple of hours, and the project's finished in a week. For something that's very large, like one of the projects we did was a industrial furnace melting 150 tons. It was thermodynamics, it was metallurgy, all sorts of stuff. It took us 2.5 months just to do the model. But yeah, that's kind of your sort of time frame, a week to a couple of months to execute a project. We also do, there was another layer to your question, and that is we do a multi-agent system where you can have AI in each of your specific, not everywhere in the plant, you'll just put it on key equipment or processes, and then we can have these economic optimizers at the top that orchestrate the coordination of optimization between the different units.
Thank you very much for a nice presentation. But I'm curious about the benefit of a value you create through your solutions. Could you give us a flavor of what kind of value or benefit you address to your customers?
Yeah, so generally when a process is difficult to control with traditional technologies, then that's where AI really comes into its own. So you get proper control of a process. Optimization technologies do exist. So for example, model predictive control is a type of optimization technology. The half-life of those types of systems is about 3 years because they actually drift over time. And what's happening as the system degrades or mechanical components wear, it just tends to drift. And then you need, top scientists to come and recalibrate or redo the system. And so what we're finding with adaptive AI is it has the ability to teach itself. One of the secrets of what we've uncovered is it teaches itself during the runtime environment and is just automatically calibrates despite the mechanical, chemical process load changes that they experience in runtime.
So how would you calculate the concrete numbers that potentially generated through your solutions so far?
So I'll give you perhaps the difficult one I mentioned earlier with the furnaces. There is massive well, it costs a lot to melt metal, for example. So in any heating application, the energy component is large. So if you can save 10, 15, 20% of your cycle, you have massive energy savings. So in transformer manufacturing, for example, where they have vapor phase drying and various other heating processes, just optimizing 10, 15% out of that process can be a large saving. It also helps to improve quality. So in transformer manufacturing, your test is right at the end of production. So if you're able to improve any of those processes, whether it's tension control and winding, or in creating, very too detailed, but any one of those processes, if you're able to improve that before you get to the end of the line, you've actually saved yourself a transformer. So.
Okay, thank you very much. Kind of a front-loading benefit or something.
Yeah, I think every industry and every application that you try has a different benefit or value. Yeah.
You mentioned that the traditional methods they drift a long time, and yours kind of lends itself. How do you guarantee that it learns from the right things? Let's say
physics doesn't change. So that's why we don't start a project with data, like asking for 5 years of data and let me analyze your data, because generally industrial data is suboptimal. So if you, because it's drifted over time, so or it's not tuned properly at the beginning, not commissioned correctly. And so if you're trying to create an optimized control solution from suboptimal data, you're going to fail. So that's why we actually start defining the control space with physics, and the physics never changes. The second step that we do on that slide is this domain randomization concept, where we look at key parameters in the process. So we look at, data sheet information, but we look at key parameters, things like friction. How would friction change over the life? And we expose the control system to millions of variations. So if your friction, let's say starts at 1, we train it to achieve optimal, even though friction might change from 0.7 to 1.3. These are random numbers. So over the lifespan, we teach it that you're going to face variation, and then we actually teach it to train itself in the runtime. One of the secrets of our company.
Thank you. Very interesting. Do you have a target industry? I mean, is it food and bev, pharmacy, or automotive? Do you have any target industry where you think your application could be more valuable?
It's a very, very diverse technology. So optimization could literally be any control loop. We've actually done a segmentation of the types of applications. So we could do, it doesn't have to be a large project. For us, optimization could just be a single control loop replacing one PID loop, and it could be in any of the industries you mentioned. Or we could do a full system, thousands of IO, something more complex. As long as it's a process, we can optimize it.
We can discuss this further, but thank you, Daniel. Our next presenters are Kader.
Thank you. Hi, everyone. Thank you for having me. My name is Rudolf Vogt. I'm the CEO and co-founder of MCADOR. And today I'm here to talk to you about how small data can revolutionize railway maintenance. So railway maintenance rely heavily on visual inspection. So you need an operator on the ground looking at something. But in the railway industry, you're facing more challenge. First of all, in most countries, we're having an aging infrastructure. Second of all, we have a labor and skill shortage where experienced operators retire and are not replaced fast enough. And on top of that, with the growing operational demands, we cannot keep up with often outdated methods. So our solution is smart cameras that can automate visual inspection tasks to free the operator from the hassle of like looking at something. So we can gather continuously without stopping operation data and analytics about everything. So we've been deploying 500 smart cameras for the rail industry for partners such as SNCF, Dutch Bahn, Wabtec, and other freight operator, where we install camera in a very versatile way, indoor, outdoor, for example, indoor in signal box, on trackside or on board. The idea is always to automate the inspection task or to assist the operator in the operation. But AI is kind of slow to integrate in the industry world compared in the consumer world where we think of ChatGPT and everything. Why is that? Because to do AI, you need a lot of data and a lot of compute. But when you're trying to do a defect detection model, you don't necessarily find a lot of defect, which is a good thing in the railway industry. But you still need those. So we develop a very specific approach. We develop a small data approach, which allows us to use a little bit of data, the one available, to be able to train a system. So when we've been benchmarking our solution, in 3 months, we are able to do what a traditional AI do in 1 year, because we skip a lot on the data collection phase. And that's what small data allow us to do. And on top of that, you have smaller models who are more efficient and more robust. So let me show you what we've been applying that to our clients. So for example, with SNCF, we have been installing our camera under the train to be able to detect defect on the rail, which allow us to avoid the operator to go on the field in a dangerous setting. We have been doing the same thing with Dutch Bahn, but this time to detect crack detection on concrete sleeper. And as we can detect the crack, we can send the information directly to the maintenance team so they can optimize their tour of repair and fixing. With 500 smart camera deployed, we have been deploying those solutions in many industry and not only, sorry, the railway industry. So for instance, to automate inventory management, or in the energy sector where we can help in water plants to do water monitoring. So it can be applied to anything, and the goal here is to help the operator on the field. So if I can leave you with like the three takeaway, and if you can remember those three things from my presentation, is one, inspection is a growing challenge. Every industry facing the same problem. You can think of Boeing. So inspection is a growing challenge. Second, small data is the way to go to adopt AI at scale in the industry, because traditional method with big data fall short. And third, impact. Because we are ROE oriented, in a sense of like we try to automate, so we want to save time, we can also with the analytics gather information to optimize maintenance, which will lead to lower carbon footprint. And that's how small data coupled with smart cameras can help the railway industry having a better maintenance. So thank you very much. I'm looking forward to have discussion with Hitachi to see how we can work on the future of maintenance. And I will lead you in the hand of our mentor, Roald. Thank you very much.
So, hello everybody. This is Roald Lengu from Hitachi Rail in Genova, Italy. MCADOR is a small but very innovative reality on which we could count for further collaboration on machine vision and more generically artificial intelligence applications, such as those related to our HMAX product. We would like to explore it more in detail the capability of building intelligence over a small portion of data used for training, as this allows to cut down on costs and anticipates delivery times. Last but not least, also the capability of designing and integrating image vision sensors is a good to have, especially related to systems such as uh, automatic vehicle inspection or other ones that we have in our portfolio. So again, MCADOR is really interesting and we would like to exploit collaboration in the future with them. Thank you.
Thank you very much. Great presentation. My question is around your smart camera strategy. So obsolescence, installation, and can you utilize the software on existing cameras across the rail network? So three questions.
Yes. So about the last one, yes, definitely we try to make camera smart when there is already camera existing. So we don't always want to replace camera. I think particularly of like the CCTV camera, where we can put our AI behind, or even cameras that are already on board. So on that part, yes, the goal is to make them smart. About the obsolescence, that's also the point of like small data. When you use big data, you usually overfit and you have something that can data drift or being very obsolete very fast. Here with small data, we have something that is very robust to change. So that's how we deal with the fact that there is data drift over time. And there was a question in the middle that I forgot.
Yeah, I think it's installation strategy. So if you have, I take it you have your own camera system.
Yes.
How do you roll that out?
So usually we have like one first project, and after where we go to install the camera ourselves, and after we just at scale like ship the camera to the client so they can install themselves with their maintenance team.
Thank you very much. I'm curious about your strategy for the business models. If I understand it correctly, you can deliver the software and hardware side as well. And so in that sense, do you have a plan to expand the manufacturing partners or manufacturing capacity in the future? And at the same time, that you have to keep some kind of a maintenance capability across the customer side on the globe. Can you give us an idea for that?
Yes. So right now, to be able to scale, we're using like a partner for the smart camera. So we buy like industrial camera, and we're actually focusing just on the computing board that we do ourselves. So that allow us to be able to scale because we couldn't do the camera ourselves. And for the maintenance, what we do, we rely on the maintenance team for the maintenance of our system. So usually it's like a very simple system because we keep a very simple design where our camera can be installed, for example, on the use case I was showing under the train over a few hours. So maintenance team can actually operate and maintain the cameras themselves unless you have to replace the whole system.
So your answer pop up into the following question is, who will assure the quality or keep the quality of your solutions?
So of course, the quality, especially in quality control, is paramount. So what we do is like we gather regularly data from the field. So of course, we configure the system, calibrate it the first time, but over time, we keep gathering data to be able to update the model. So what we did for SNCF have been useful for Dutch ban and will be useful for the next clients because we're reusing those data to make sure like we have like a better model over time.
Such a usage of the data at some specific customer site is included in a contract with the other customers. You can reuse the data out from one specific customer to the potential customers.
So it very heavily depends on the use case. There is some use case where there is like an exclusivity on the data and the model must be specific. But for example, when working on inspection of assets that are very common, such as a rail or concrete sleeper or fault detection for train, all of that is something that benefiting everybody to have the best model over time.
Great, thanks.
Thank you for your good presentation. So my question is about endurance of the cameras. Are you using as a smart camera, are you using a specially tailored made one, or you're using a commodity camera?
So yes, we're using specifically industrial cameras that are robust. For example, I'm working from Canada and there is snowstorm. So we're using specific cameras that are able to withstand specific condition where we deploy them. So we have not a specific partner because sometimes we have to source for specific usage.
So when you apply this solution to the moving vehicles, so I guess it's very harsh environment. So how do you assure the endurance? What is like? How long is the lifetime is?
So we have a partner that tests the camera. So we do stress tests on the camera. And we also rely on experience because it's been like 5 years or 6 years we've deployed the first camera. And over time, we have spotted what makes the design weak at some places, especially, for example, when it's very cold or things like that. So yes.
Thank you.
Thank you for the very simple messaging, clear presentation. I have a doubt around the overall business volume or value you can create at the end. It seems to be niche application, which is very good. But my question is around scalability and how can you go to other industries? It seems your solution, you need to do some learning. Like let's say you apply your system to not railways maintenance, but in an industrial settings. So my question is how hard would it be for your algorithm to learn defects and issues in other industries so that you can scale the potential business you can have with your approach?
So it's definitely a challenge for us. So we deploy like 500 smart camera over like maybe 20 use case. And for instance, we recently got into the logistics side where we did inventory management automation. And yes, when we enter a new use case, there is a learning phase. And the whole idea is because we use small data, we can cut down on this learning phase. So the whole approach we have is like we rely less on a huge set of data that will take a long time to collect, but the ability to work with smaller amount of data, which is coming from synthetic data or GenAI. Seconds.
All right. Now I feel stressed. So, is any processing locally that so you do some of this processing locally, or is it kind of offline if you try to do and check maintenance, for example?
It's online in real time, and I will find you after and answer in more detail. Thank you very much.
Yes, next we have Annie Locke. Sorry. The floor is yours. We cannot hear you. No.
Can you hear me now?
Yes. Yes,
Okay,
all good.
great.
Great.
All right. First slide, please. And hi, great to be here. My name is Moshe Shadmon, and I'm the founder and CEO of Venilog. Today, most enterprise data is generated at the edge, whether from solar panels, smart cities, substations, connected cars, and many more. However, there is no efficient solution to manage the data where it is created. Companies have no choice other than moving their edge data to the cloud. Anilog changes that. Our software platform is deployed at the edge, transforming it to an intuitive, simple, and unified data platform. Next. Next, please. The diagram shows how edge data is managed today. Edge nodes capture the data from the PLCs, and from there, the data starts a journey to the cloud. At the cloud, the data is hosted in databases, and only then data can service the applications. Next, please. With this approach, real time is no longer there, data sovereignty is lost, and we're all aware of the complexity and costs in building edge solutions, moving data to the cloud, and leveraging cloud services. Next. Let's see how Anilog manages the data. The starting point is exactly the same. Edge nodes capture the data at the edge. The difference is that Anilog is deployed on these nodes. Next, please. By deploying Anilog at the edge, a virtual layer is created that spans across the entire edge. And the claim is that this is the only thing that needs to be done to make the data available. From here on, the data is available to any application that needs the data. This layer, now go to the previous one. This layer represents, previous please, previous slide. This layer represents the data in a unified way. That means that applications query the data from a virtual layer just as they would do in the cloud. The same SQL queries that connect, the same SQL queries that once went to the cloud can now be routed directly to the edge. Data can still move to the cloud, but much less data, because the edge can now handle the queries that previously had to be executed in the cloud. Next. This approach counters what companies are doing. Instead of moving all the edge data to the cloud, where queries are executed, Anilog moves the queries to where the data resides, at the edge. This method is far more efficient because only queries and result sets are moving on the network. It is fully automated. It is an open and unified platform that eliminates data silos. It enables real-time insight, and it reduces cost by a plug-and-play approach at the edge and by removing or reducing dependency on data services at the cloud. Next, please. Some examples of success stories. Anilog is deployed in the city of Sabetha, Kansas, and manages all the city's infrastructure, which is electricity, water, and wastewater. Anilog was deployed in days, and 2 weeks after it went to production, the city asked to terminate their cloud contracts. In energy, we're doing a very large POC with Nov Energy to deploy Anilog on onshore and offshore oil rigs. For battery management, Anilog is deployed on large electric tourist boats in France and Switzerland lakes. And in smart homes, we were deployed in smart buildings. This use case also highlights the value in keeping data in place to maintain data ownership and support regulations. In addition, this project leverages Anilog to enable federated learning at the edge. Next, please. The implications are enormous, from enabling real-time insight to automating deployments and enabling federated learning and data sharing. Thank you.
Thank you, Moshe. Now we'll have your mentor, Christine, give a few words.
So, hi everyone. My name's Christine Cunningham, and I lead a digital innovation lab at Hitachi Energy. So, I've worked at Hitachi for 14 years across, I think, 4 of our group companies. And what I've seen is that so much of our focus is on how we get more insight and more value out of the data that we have on our assets that are out there in the field, right? Whether it's trains or transformers. So, I'm really excited to have met Anilog because they're really addressing some major challenges around how you access this data. Their value proposition is relevant to all industries, really, and it's strong. And our team at Hitachi Energy also think that their solution might help us and be relevant to the European Data Act. So we're actually already discussing signing an NDA with them. I've sat in a few user group meetings that they've had hosted, and I've heard about some of the great use cases that were just mentioned with current customers. And they actually have some really great partners already, like Linux Foundation. They also have a strong team with a great track record. So I hope their pitch also excited you all. Thanks.
Thank you. We will start with the Q&A session. Do we have a first question from our judges?
Thank you, Moshe, for the very clear presentation. Anilog is like some sort of edge hardware, but I saw that you have edge apps. And in your business model, where is the value in Anilogs or creating the edge apps? And if this is the edge apps, who is the creator of the edge app? Is it a closed system or an open system for anyone to do apps?
Yeah. So first, we're software only, right? So it's a software solution that deployed at the edge. And it's one of the core ideas is to make the data available. So we make the data open and available using standard APIs and moving a lot of the things that usually go to proprietary and legacy systems. We make them available to anyone that needs the data, obviously if it's got permissions to do it. So we're kind of tapping into a place where data that was captured becomes very open and available using plug and play software.
All right, but just to try to understand the value, where is the value in your business model? So is the value is to render data available and then you have a fees on this, or is it like the edge app on top of which will create value?
Well, the value in terms of our business model, we just bring the software. So we bring the software and customers deploy it on their edge infrastructure. So our business model is based on subscription based of the software. The applications, anyone could connect any application that he wants. And that's one of the things that we're focusing is to create an ecosystem. And there are lots of startups and larger companies that are building on top of us.
Thank you very much, Moshe. Really interesting presentation. Who holds the IPR in that situation? So my understanding is it's a software as a service approach. But do you work in terms of your contracting around the IPR specifically for the organizations that you work with?
So we just give the software. We don't give it as a service. You license the software like any other software that you would license, and you deploy it on your hardware. We don't tell the customers where to deploy it. Some deploy it just on site, some deploy it in some data centers. In most cases, it's some kind of a combination. You deploy it wherever you want, and you create a virtual layer that spans across your entire edge. We don't have access to the data. The data remains in full control of the data owners, which is a big value proposition here. And we just, our business model is just to license the software, and we're being deployed wherever the use case requires the deployment, and it's done by the customers.
Thank you.
So, what is the benefit of your solution versus any other of the current hyperscalers that they also have collect data from the edge? They have a bunch of solutions on the cloud as well.
Yeah. So the value proposition is that you don't move your data to the cloud, or you could reduce the data that you move to the cloud. So, for example, the city use case, it's a city that deployed us at the edge, connected their dashboards and applications to a virtual layer that spans across all their edge nodes. And now this layer service their dashboards and applications and AI, and they decided we're not going to use the cloud. So no data moves to the cloud, which is huge efficiency. Data is available in real time, huge cost savings, and the entire deployment, creating this virtual data lake that spans across your entire edge, is a plug and play story. It was done in days, replacing months and months of work that they had before integrating or leveraging us to move the data to the cloud. All this work is gone, and all the associated costs in building infrastructure that sends data to the cloud is gone. There is another value proposition which I think is very interesting for Hitachi. It's the same software stack and the same approach that you could take from the rails to Hitachi Energy to any other use case that you have in mind, rather than specific solutions per use case. So I think the value proposition is enormous in terms of being able to unify and make data available in a very efficient way and at a very low cost.
Moshe, sorry, again, maybe a disruptive question. It looks like it's an edge cloud. So do you think ultimately your client will be, Amazon, Google, Meta, because they will fear that they will be disrupted by your solution?
Well, I think in that sense, that's one of the reasons that we're very interested to work with Hitachi, because I think that yes, the cloud providers would feel threatened from something like that, because it basically says, you customer, before you move the data to the cloud, you could put a virtual layer that doesn't cost you anything across your entire edge and run many of the queries that traditionally would go to the cloud. You could run them against your virtual layer, but at the same time, it creates a huge opportunity, because every percent of data that remains at the edge and doesn't move to the cloud makes Hitachi, or companies that wants to deliver this solution to their customers, makes it a multi-billion-dollar opportunity for them, because with this approach, edge data is serviced to the applications without intermediaries, which means that the opportunity to bring this data or solution to the customer makes Hitachi, in this case, the data service provider for edge data. So it's a win-win situation. It's lower costs for the users because they need to move less data to the cloud and leverage less data services. But at the same time, it could put Hitachi as the data service provider.
Thank you, Moshe. Time is up. We
Thank you.
now have our thank you. So we're running very efficiently today, so that's super good news. So we will have our last pitch before we have a small break. So the floor is yours, Mark.
Yeah. Hello, Martin Kunze, one of the founders of Zerabyte. Since the beginning of the digital age, data is stored on devices that were originally designed for computational storage and not for storing data for the long term. This is why data storage today is extremely unsustainable. Permanent energy consumption, limited lifetime of media require frequent replacement, data migration, which results in high costs and an insane footprint on ecological and economical scale. But there is an even larger challenge. Roughly every 30 years, the amount of data grows 1,000-fold. And within the next 2 decades, the industry needs to improve by 100 times storage capacity, performance, energy, and cost efficiency. The problem is mainstream technologies fall short on scaling. They've reached their potential of exponential growth. And even on the best case scenarios, the industry could deliver only half of the demand. The supply gap is looming, and rising costs for storage can cripple AI business models. Billions invested could be at risk. There is a material for keeping information which has a track record of thousands of years. Zerabyte uses thin glass foils from the display industry and coated with a dark ceramic layer with punched data matrices, which creates physical bits, and they remain there virtually forever, even under harsh conditions. This is innovation number one. And the second is to use a DMD, a digital mirror device, to shape a laser stamp to punch these matrices with 2 million bits with one shot. Data is read out by high-speed image sensors, and the data carriers are stored in cartridges with the shape of LTO tape. By using existing technologies and materials and form factors, this enables us to scale and simplifies implementation on customer side. Zerabyte uses amortized semicon fab tool technology. The digital mirror device, the DMD, was developed 15 years ago for maskless lithography. Now it is used to write data. Today's technologies like particle beam and focused ion beam also work on our material. And this will lead to the data densities which are required in 10, 15 years from now, where no other technology, nor exist neither emerging technologies can scale to. And this is also the reason why 2 major storage manufacturers have already invested in Zerabyte. Our strong patent portfolio allows us to orchestrate a multi-source supply chain. And the business opportunity, you can imagine, is huge. In the future, coined by AI, there is no other option as to rely on the broad basis of data storage, in best case immutable storage. A new storage solution is eagerly expected already for years, and a recent report from the national academies attested Zerabyte to be far ahead of all emerging technologies for permanent data storage. By improving capacity and performance, Zerabyte will gradually compete with mainstream technology specs and undercut the costs for today's data storage, and initial customers will benefit from rising performance and dropping media costs. There are many impacts, and I just want to point one to one, which is still unnoticed to the AI community. Without an abundance of low cost and sustainable data storage, AI will not be able to unleash its full potential. We partnered with a couple of experts from the storage industry, for example, Steve Campbell, former CTO of Western Digital and Hitachi Global Storage, John Colgrave, founder of Pure Storage, or Stefan Helmut with 30 years experience throughout the whole stack of data storage. Oops, where's the last one? Oh, here. So there is a couple of synergies, and I will be happy to partner on the leading future technology for sustainable data storage. Thank you for the opportunity.
Thank you, Martin. I'm the mentor, and I was quite impressed by that solution because it's really looking forward into the mid to long-term future and identifying the data storage gap and opportunities in terms of sustainable storage. This reminds me to the ARC project of Hitachi for the storing humankind and information 2015, and that's a nice follow-up. And I think this is an opportunity for Hitachi, not only for the data storage in this context, also looking for open source reading and writing software solution, which is also essential for 50 or 100 years time. Somebody need to read that data. So there's an opportunity to collaborate with the Hitachi open platform solution, which just has been found the end of last year. So in this context, there's also an opportunity to collaborate with HITACHI for laser and laser reading and writing technologies. And in this context, I think it's a very powerful solution and it has a lot of potential. So I think it is an opportunity for Hitachi for mid to long-term future. Thank you.
Thank you, Peter. We'll now start with Q&A. First question.
Thank you very much for that nice presentation. But I'm curious about market potential. I understand the gap of the storage needs, but your solution, if I understand correctly, your solution is about once the data is stored, the read-only solution, right?
That's correct. It's
So in that sense, maybe the market is limited to some kind of a archiving needed.
That's what we thought at the beginning as well. But look at your laptop. I think there is 99% of data you don't use on a daily basis. You don't want it to disappear. It's the same in data centers. It's data which is stored over decades and almost never deleted.
Yeah. So you're targeting kind of an archiving or backup market potentially? How
At the beginning, yes. Yeah.
size of the actual market?
Yeah, so the first customers will be from those who will store data for 100 plus years. National Archives, CERN, for example, who is invited us to partner in the Open Lab program. But gradually it will be so cost efficient that it will also be interesting for the hyperscalers, what we're already talking with.
Yeah, thanks.
Thank you for the presentation. You showed some sort of roadmap in one of your slides. So my question is, how mature is the technology today in terms of testing in reality, and when is like the commercialization date you believe, like with a real industrialized storage system?
Yeah, we built a working end-to-end prototype already with commercial off-the-shelf parts. Our first customers will be CERN, for example, with the testing of the material under extreme conditions, the first terabytes in cartridges, and the first library systems will be delivered next year, and then start to fill with the rising capacity of the cartridges.
And additional question, what about waste management with your?
It's 100% recyclable. It's glass. Yeah.
Okay.
I'm glad you mentioned the National Archives, because a few years ago I was working with them to do a data storage strategy. And one of the things that they put me off guard is they say that they have a mandate to store data for the next 100 years from the government. You're a startup. How are you going to make sure that you're going to be here for the next 100 years to make?
Yeah, that's a valid and true question, of course. We deliver an open algorithm to write the data, so you'll be able to read the data So we develop everything an IT expert in 100 years needs to know to access the data. It's optically readable as long as there's scanning microscope and the algorithm is known, then you can read the data. I will tell you in nice experiments we did in a conference afterwards.
Thank you very much for presenting a very interesting technology. So my question is, could you elaborate more about the benefit in terms of the cost and footprint?
Yeah, the costs today for data storage rely on the energy consumption and the frequent replacement of the media. Every 5 years or less, they need to be replaced. The data lifetime is much longer than the lifetime of the media. So that's one cost benefit. And energy-wise, it's about 20% of the energy in data centers for maintenance of data. It's not processing data, it's just migration, fixity checks. It's unproductive time and energy spent on just data maintenance.
I'm not aware of the kind of a readout system, but when you read or write, is it more energy consuming than the current technologies?
We need about 1 nanojoule to write 1 bit, and then it's there forever. You don't need any energy to maintain a specific atmosphere. You don't need air conditioning. It stays there. You can have it in the Arctic or in the desert. It's, yeah.
Basically, if you think of the life cycle cost, so it's
right.
some benefit to that. How about the footprint, the size of the...
Yeah, so we try to get data from data centers and from producers, from manufacturers of hard drives and SSDs, and they still can say what their actual footprint is. Here, it's glass, it's produced for displays. The production process is very simple. It's very easy or simple to produce a data carrier. It's glass, thin glass, which is a drop down or a coating process, coating with this thin ceramic layer, and then it's ready to write. Imagine how many procedures. It's about 500 steps until a SSD is ready to be written. Here it's about 20, if it's so much.
Thank you.
Thanks. So thanks everyone. Thank you for the first 5 startups who pitched. We will now have a short break until 10:30, so it's around 10 minutes. Yeah. And we will resume at 10:30, so please be on time and thank you.
And then please take the drinks, and then also in the fridge. And then next door, there is some snacks, chocolate and then chips. Please take it whatever you want. And then also in the middle of the office, there is another coffee machine. So please use it.
Okay, everyone, we should be starting in 1 minute. If we could please start taking your seats again. Thank you. Yes. So break is over and we will resume with our last 5 pitches. If we could all regroup here, please, so we can start again. Just wait for our judges at least to resume. Great. Still have one missing judge. and someone else. No, I saw you. Okay. So this was a good break to energize. Okay. Great. Mm, 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 mm. Okay, great. So now that we have most of everyone here and our 6 judges here, we can resume with our second part of the pitching session. So I would like to invite Philippe from the Cross Product to take the stage.
Hello, everyone. My name is Philippe from the Cross Product, and during the Q&A, I will have a question for you. Why are we called the Cross Product? You'll have to guess. So the Cross Product, we are LiDAR point cloud LiDAR point cloud processing experts. I'll start with this. A year ago, I hope there's no one from Renfe here, but a year ago, Renfe, there was a bit of a scandal there because they spent 300 million euros on designing trains that would not fit their tunnels, which is kind of stupid. 300 million euro were lost. So how to avoid this? To avoid this, you need a representation of your infrastructure and to be able to simulate a train within that infrastructure. For this, we use LiDAR technology. So you all know what is a LiDAR because you have one at home. This kind of device is a LiDAR. This is about 20 euros. Those are about €1 million each piece. So those LiDARs here, this is a French train. I'm from France. French train, and here we have a LiDAR from Omnicom, Omnicom being a Hitachi company. Those LiDARs, they acquire 1 million points per second in the environment, and they generate what we call point clouds. So this image here is not an image, it's a list of 3D point clouds. As humans, we can see something here, rails, poles, but a computer cannot see anything. It's just a list of points, 3D georeference points. So what we do at the Cross Product is we build algorithms to extract information from those point clouds. So we are a software company, and the first thing we do is extract the rails, the center lines, the wires. once we have this, we can put train gauge, a rolling stock gauge on the rails and simulate the rolling of that train to avoid clash with the infrastructure or the tunnels in Renfe. We also have other algorithms that are able to analyze the alignments, vertical and horizontal alignment of the tracks in 3D. This is very useful for signaling projects, such as ERTMS in Europe that is aiming at renovating 100,000 kilometers of signaling within the next 25 years. Those alignments are usually analyzed by track engineers, about 1 day per kilometer. We do it 200 times faster with processing. Next slide, please. Why to choose us? Because we are hardware agnostic. So we can process data coming from Omnicom LiDAR, from SNCF LiDARs, from terrestrial LiDAR, from drone LiDAR. We are a software company. What we do is 100% automated, enabling large-scale infrastructure to be analyzed, and it's cloud-based. And we have an API. We are a back-end application able to integrate into any front-end or system-to-system integration. Thank you very much for listening. I'm happy to have your question. And remember my question, why are we called a cross product?
Hi, I'm Carmine Yapika from Hitachi Rail STS Italy, and I'm working in global operational improvement. And then my approach in the selection phase was the safety improvement mainly, and then also the sustainability approach. The TCP company is a small startup made up 11 people with 7 PhD, and this is specialized on the application software to analyze the big data, three-dimensional data coming from hardware system installed in any type of vehicle, transportation vehicle, commercial or not commercial, is independent from the use of the installation of the type of the vehicle. Also in automotive is possible to use. And then the special approach to analyze the big data and in coming from the cloud with the algorithm based of intelligence artificial to make a fast response and also with high level of precision is fundamental, very, very important to improve the safety in transportation. Thanks.
Thank you, Carmine.
Hi, thank you very much for the presentation. What couple of points. What's your primary role in terms of what data you provide? So from a UK perspective, our infrastructure is fairly old, fairly traditional, and well known in terms of, and there's quite a lot of competition in this space from a gauging perspective. So what's your primary application? Is it about understanding providing data in terms of new trains that operate on the route? Is it related to what information you can provide from a maintenance perspective, so movement of infrastructure? We saw recently a very sad safety case in the UK where there was an incident because of movement of infrastructure. So what is your primary objective?
Yes, so thanks for the question. The best-selling product today is the alignment analysis product. So to convert rail polylines into alignment, vertical horizontal alignment. This is sold 500 euros per kilometer today in France. And there is a project in Europe, ERTMS, that is about 100,000 kilometers long. So if we just multiply those two numbers, you get a high volume of sales. Of course, the price will go down with volume. But the best-selling product today is the alignment product, and we've raised the interest of Bentley systems. We are currently integrating this product as a back-end application to the front-end application that is Bentley Open Rail Designer. So I would say alignment analysis, which is a second level of application from point clouds. From point clouds, you get the geometry, you get the polyline, sorry, and then from the polylines, you get the actual geometry, which is alignments, spirals, tangents, and curves in the horizontal vertical planes. This is the best-selling product today. But we also work with total energies, which has nothing to do with rail, to to verify the completeness of their data once they go on an offshore platform, acquire thousands of LiDAR terrestrial point clouds, and they send this to us, and within days, a few days, we're able to verify the completeness of it. So we are able basically to we have competition in UK. We have D-Gauge. I'm meeting them tomorrow. We have Fugro also. We've met them 2 years ago. So we know our competition, but we are probably an R&D subcontractor for them. So we are probably able to make their products better. I'm meeting D-Gauge tomorrow. Thank you. In Birmingham.
First of all, I don't have an answer to your question, but anyway.
I forgot to answer that. The one who answers this question wins this. Come on, the cross product. What does it mean? Go ahead.
Yeah, my curiosity is going to your technology itself. What is your uniqueness in terms of a point cloud or 3D modeling,
Sure.
especially for the autonomous driving space?
Okay, so autonomous driving is using LiDAR too, but those are front-facing LiDARs that are real-time LiDARs. We don't do real-time at all. We gather the data and then we post-process it. So that's the differentiation with real-time. And the unique selling point here is, for us, is that it's fully automated. So we are really for large-scale networks, where you take all the point clouds from network rail in one go, and then extract the geometry for the whole network in a few days. So we are aiming at large-scale products. That's why D-Gauge is interested with our products, because sometimes they get surveys where they don't have polylines. They need to extract those polylines, and then they need alignment from there. So we are aiming at large-scale big data, and we are back-end applications. So we don't want to have a viewer or anything like this.
So what is the secret sauce to realize this?
Okay, of course, I cannot reveal the secret, but everything is proprietary. So the 7 PhDs we have, they generate the software, and this is proprietary. We use AI. Yes, AI. I didn't mention it. We use mathematical morphology. So basically, we are in a 3D environment where mathematical morphology applies, and we combine this with a bit of training with AI. We don't need a lot of samples for training, and combining AI, mathematical morphology, and business knowledge like rail. What is rail? What is a track? Then combining those three, we're able to generate our products.
Got it. Thanks.
If I remember well my mathematical classes some years ago, there were like 2 vectors, and when you cross them, you get like in a third dimension another vector.
The winner is André. Sorry, it's secondhand. It's my home telemeter. Yeah, the cross product means when you do a vector cross product, you multiply x vector times y vector, and you get the z vector. So that's the cross product.
All right. So
congratulations.
Thank you. So maybe I have 2 questions, maybe related to the cross product. On the first one, to which extent, when do you need to use a LiDAR because you cannot use a normal camera?
Camera doesn't provide 3D information.
Yes, but if you can infer, let's say, 2D information in the camera.
Well, photogrammetry is poor in terms of 3D.
So it's accuracy, and then
it's sub-centimetric and or even millimetric, and sometimes relative accuracy is millimetric. Absolute accuracy is centimetric. So LiDAR is much more precise in terms of geometry analysis.
Than the industry we're talking about, because of accuracy, you can't use camera. Basically.
Well, and I'm not sure even if you would put a camera on a train and run Pix4D or any photogrammetry software on it, will it work? Because there's just too much information.
Okay, so now my question on business model and volume. I wonder, I mean, one LiDAR system is 1 million.
Mhm.
You're not pulling through this system into your books. So I guess the client buy this system.
We don't deal with hardware at all.
You don't deal with hardware, right? So I mean, what is the business volume potential
Yeah.
that you have with this technology? If this is very niche to, you know, tax adjustments or things like this. Like, do you have an evaluation of what's the business volume potential?
We are a startup, so we're discovering this. If we just take ERTMS, we've run a pilot with ERTMS in France, computing the alignments for the ERTMS project as a pilot project. If you multiply 500 euros per 100,000 kilometers, that's the opportunity for ERTMS only.
All right. Hi, everyone. This is Kayra Kakçoğlu, founder of Data Lobster. So we will be talking about industry, sustainable industry. And the keyword that I would like you to have in your mind is not the AI, is not the IoT part. It is the plug and play part. Okay, so this is where we are going to focus on. So we know our industries, we know our expectations, we know how beautiful we want it to be, easy to access, like everything is beautiful, all connected. But we also know the reality, right? And there are reasons why we are not where we want to be, even for large corporations, you know, such as Hitachi. So the problem statement is that we are having difficulty gathering data from the equipment. And another aspect is that we are having even more difficulty using the data that we are gathering. So why is it difficult? Because connecting to each equipment is time consuming, it's costly. You have a variety of equipment. Then the data that you get is unstructured. It is generally challenging to deal with. And we do not have, you know, most manufacturers do not have the right infrastructure to deal with the big data and to apply AI algorithms on it. And it also requires a special skill set in terms of people that is generally difficult to acquire. So we have built 3 different services to deal with these challenges. The first one is the AI Factory, where we create scalable solutions to deal that we can apply for any type of industry, so we can generate the insights that the industry needs. The second one is Digital Now. It's a tool. It's an IoT capability. I will try to show you if I can. So a small device similar to a matchbox that you can put on any industrial equipment, and it generates the activity. It can learn the activity of any equipment. It can understand when it is running, how many cycles it's completed, how many products it generated in a few hours. And then the third part is the service platform that helps our customers to serve their customers by using our own platform. Okay, so that's a bit dark, but just to give you a few use cases, right? We can talk a lot about the AI, but actually the real meaning is what it delivers. So I'll tell you a few about the use cases that we have had. So the energy savings in water distribution, we are working with Municipality Istanbul, and we have finalized the first phase of the project that are going to save them 15 million euros a year by just applying the right AI algorithms at the right level. We are working with anomaly prediction. One of them is the electric furnace. So here we are seeing that we can predict the downtime. I mean, actually the failure of the equipment 6 months in advance. We have also been working in shared mobility businesses, completely different aspect, but our platform can definitely handle that. And we are also working with process optimization to determine what would be the highest quality parameters that would enable our efficiency and in the industrial setting. If you are talking about the digital now use cases, here we can look at predictive maintenance for any asset, literally. And then we have maintenance and energy cost reduction up to 80% for maintenance cost reduction, because we are maintaining equipment that we do not use actually. And then asset performance improvement, because it is all out there. We are monitoring it 7/24. So our implementation time is 2 days, up to 80% improvement opportunities, and we are and 20% energy savings. The important part is today the current market is valued at 3 billion, but actually the full market, when you're taking all the market size into consideration, considering all the assets that are available, it's actually 27 billion. That also shows why we need simple and plug and play solutions. So I will skip those parts. So we have won quite a few awards, luckily, and I'm hoping that we will be able to add another one here. But we have already been very lucky and happy to be supported by Hitachi team and our mentors. So thank you for the presentation.
My name is John McKisk. I'm with Hitachi Energy. I lead environment across our operations globally, and I will say that we had co-mentors for Data Lobster. We also had Pablo Orvanos with Hitachi Digital Services, who leads sustainability for that team. And I'd say that he was the primary mentor for Data Lobster. So I don't want to steal his thunder by any means, but I'll do my best to provide you some insights from my perspective. What really caught my attention and stood out with Data Lobster was the simplistic plug and play aspect that Kara described for us, and the ability for really any organization to deploy this technology relatively quickly and simply across their manufacturing facilities and across their assets. And then it provides just about any organization the ability then to turn any of their legacy assets or equipment into smart assets and then do something about it to enhance manufacturing and operational efficiency, and also drive energy efficiency improvements and other things along those lines, which is closely in line with Hitachi Energy's environmental vision and ambitions, as well as the Hitachi Group overall. So I know that Data Lobster and the HDS team and Pablo have already started to explore some potential opportunities with clients. So I'm sure they're looking forward to continuing that collaboration, and potentially we are across Hitachi Energy as well. So that's all. Thank you.
So questions from jury members?
Thank you very much for this presentation. But my question is because of maybe I couldn't capture everything, especially for the sensor side. Is that the sensor about the seismic approach or electric currency? Or that why can you capture just putting the sensor on top of the equipment?
Absolutely. So we are capturing a lot of information. I mean, it's a multi-sensor on its own, and we are capturing vibration information as you have imagined, but also magnetic field, which gives us an understanding on the energy consumption of the equipment, as well as a gyroscope, which is kind of the turning events, and light, temperature, humidity, etc., and various ambient information. So it's a plug and play device that you just put on the equipment. We don't need to go there. We don't need to even, I mean, we're just shipping it to our customers. They put it in and it works. It just learns fast, and next day you have your dashboards across all your factories.
Okay, yeah, it must be simple, but on the side, the heavily dependent on the implementation at the customer sites, and also the requirements from the customers AI model sides as well.
Yeah, so for the device side, we learn what that equipment is doing, no matter what that equipment is. So we have been in a challenge, for example, with Danieli Group, where they have given us data that we did not know what equipment it belonged to, which each column represented, and what in what type of measurement unit. and we have been able to understand anomalies, etc., without any error. So our AI side is equipment agnostic. We don't need domain knowledge. But when you are, applying lobsters on the devices, like for the digital now, it obviously, I mean, we recommend certain locations depending on where the customers are planning to put it in. But otherwise, I mean, we never intervene. They just put it in and they see the data. If they want to improve, they want to change things, they do it on their own.
Interesting. Thank you.
So yeah, so my question is can you describe once again exactly the value proposition? So my understanding is you have this kind of sensor or mobile sensor you can put, maybe you have collection of these in a given site, but what you provide as a value is the ability to read fast behavior of various equipment, but anything downstream of it, which is optimization, are you going to kind of consult the client or give advices over the long term, or this is a one-off and then data readouts and they do whatever they want? So what's the real value proposition behind?
Sure. Generally, we have an onboarding phase. So during the onboarding phase, that takes generally 2 to 3 months. We have a weekly meeting with the customer, looking at their data, because the customers, they are not used to deal with their data. They do not know what to do with it. So we give some recommendations. So we have some, automated dashboards that allows them to see what is the potential value that they can generate depending on the production line. The value that we generate, it is, I mean, we have spoken a little bit about like deep solutions in here. Here we are talking about broad solutions. So for any type of industry, for any type of equipment, we can learn what that machine is doing, when it is running, is it running on the right time or not, is it when it's supposed to run, and is it generating the right cycles, right? The cycle time is too long, too short, etc. And are there any performance differences between equipment? So that's just knowing that when that machine is running. It might sound very silly, but just to know when that machine is actually running or not, it actually allows you to improve your performance by 10 to 15% in any industrial environment. And on top of it, there are, other, when you're thinking about on the energy saving side, I mean, we have a customer that have been running their equipment 17 times more than they were supposed to. They just realized it with us, and that reduced to 2% because we are sending automated alarms directly to their operators, not to the management, to the operators, so that they are, shutting down the equipment. It's sometimes as simple as that.
Sorry, can I reverse the question?
Of course.
So if you would have to keep one part in your solution, will it be this sensor or will it be this AI dashboard algorithm?
Yeah, tough question. So in the end, the product, the Lobster is a product today. So that is an easy to deploy, generates revenue, fixes problems. The platform is the real brains behind it, but it is not a platform that we can, 100% that give it to our customers at this stage. So our intention is to make the platform a product as well, as we're going forward. But in the beginning, the Lobster is our main distribution.
I had two questions, but the second question was the same as him. And then my first question is some confirmation about the sensors. Is it a configurable one? So you can change necessary sensors, or single sensor can detect anything?
So we are not configuring it. We prefer the multi-sensor approach because it gives us a breadth, I mean, a detail of information that is not available sometimes, and it makes it equipment agnostic, right? Sometimes you are more depending on the magnetic field information. Sometimes you are more in the vibration information. So it varies from case to case. Sometimes even with light detector, we are counting parts and different use cases. So, but we are working with ST Microelectronics, who is also our partner, both on the R&D side, but also to develop a new multi-sensor together.
Okay, thank you. Why do you name company Lobster?
You want the real answer or the commercial answer? Commercial. Well, because lobster is an animal that gets better with age, actually. It's the only animal with age and with time, they get better, they get more fertile, etc. And the only reason that they die because they need to change their shells. So we get better with time as well. With more data we have, better we are.
Thank you.
Next up, we have HITACHI online. So the floor is yours.
Hello, my name is Shahar Belkin, and I'm the privileged to present ZutaCore, the company that will create sustainable AI data centers. Next. ZutaCore was established in 2016 in Israel and has offices today in the US, in India, in Taiwan, in Europe, and it already has 70 employees around the world. ZutaCore is leading an ecosystem partnership with a lot of the companies in the field that some of them already invested in ZutaCore that you can see here on the screen. The next. ZutaCore is entering a field of the AI data centers that, although bringing a lot of good to the world, actually brings a problem in sustainability while using a lot of electricity and a lot of water use. Millions of gallons of water are being used to cool the data centers. Next. What is happening in this data center, in this industry, is that GPUs are being powered up, and power of GPUs is now past the 1,500 watts per GPU. And that is creating a very strong demand for cooling. That system that were cooled by air recently or by immersion cannot cope with that power anymore. And even what is called the water-based cold plate that is generally used today for direct-on-chip liquid cooling is stressed to its limits. As for water cooling or single-phase cooling, cooling is based on the flow itself. That means that the flow needs to go up to 3 liters per minute for 2,000 watt chips that are coming in 2026. And if you see a cold plate like this, you don't see exactly how physically you can stream 3 liters per minute through this. Next. I want to explain why two-phase is actually the best solution for cooling high-powered chips with very high heat fluxes. Well, the example is very simple. When you have a pot of water on a fire, the water, when they boil, are at a steady temperature of 100 degrees Celsius. Even if you double, triple the fire, or 10 times more fire, the water will not pass the 100 degrees Celsius. Now, the water have a single task here to make a soup, but they also cool the bottom of the pot. So if there won't be any water, the pot would melt. And this is exactly what the cold plate that ZutaCore developed does. There's a pool of liquid in the bottom of that cold plate, and that liquid boils because of the heat of the chip that is underneath. That vapor comes out with the heat, goes to a condenser, being condensed, and then spring back as liquid into the cold plate. This is a simple task, but it's a very complicated one because next, there is one big hurdle in doing that kind of cooling. It makes a lot of logic. It seems very sensible and the physics works for you, but the bubbles on the surface of the cold plate doesn't bother the pot, but when they are trying to cool a GPU or CPU, there's thousands or hundreds of thousands of transistors under every bubble. And that bubbles create a spacing between the liquid and the surface and creates a hotspot that in the GPU case, thousands of transistors will heat up and stop working. Next, ZutaCore actually solved that problem after many, many companies have tried to and created a unique patent structure of fins and wick. Wick material is actually a porous material that the liquid is saturated inside the wick, and the boiling is happening between the porous material and the fins and not on the bottom, preventing bubbles from being on the bottom. Next. So the ZutaCore solution is very efficient because the flow into it is only 0.3 or actually 20% of what we saw in single phase, and it is controlled by an on-demand mechanism that only the needed flow will go into the cold plate when the heat is up. Go next. Very, very efficient, covering all the space of the chip. Same kind of cooling will be depending on all the on the chip, doesn't matter what area. Next. And efficiency in the data center, 40% less energy, 90% less water usage, and the ability to reuse the heat again and create energy out of it. Thank you very much.
Thank you.
Yeah, so it's Patricia again from the Environment Business Division. I had the pleasure of co-mentoring ZutaCore together with R&D Japan as well. So I just want to highlight that. I think we're all very excited about ZutaCore for 3 reasons. One is they're really serious about sustainability, 40% less energy, 80% less water. They didn't mention it, but they also require 50% less space. And so it's a waterless cooling technology that we haven't seen before. Number 2, ZutaCore is sort of ready to scale. So this is a little bit more advanced startup that I think is, in terms of size, is a very nice fit for what Hitachi also is looking to do in the data center segment. And 3, if we think about data centers and sort of the 4 elements of a data center, we have the electrical infrastructure, we have the IT infrastructure, we have the digital infrastructure, which are all quite well covered by Hitachi, but we also have the mechanical infrastructure, the cooling side, which is less covered by our current portfolio. And I feel ZutaCore would be an excellent fit. Thank you.
Yes, questions?
Thank you, Shah, for this very nice presentation. One question regarding manufacturing scalability. You presented, a very well-defined geometry where you have a pattern with fins and other things. So my question is, what about manufacturing costs of this solution versus the energy saving you do? So in simple terms, CapEx versus OpEx of your solution versus other solution. And do you have a certain manufacturing volume you should do at least to be cost competitive? So do you need very large manufacturing centers?
So good question. ZutaCore has decided not to have its own facility for manufacturing, but it's using third-party manufacturing. For example, one of the company that is third-party manufacturing for us is Valeo from France, that is actually from the vehicle industry, and the volumes there are actually unlimited. But we're working with others and happy to work with other companies that are third-party manufacturing. Part of our components will actually be manufactured by our customers under license. We don't expect to be a big manufacturing. And for the CapEx size, if you're planning a data center that will be cooled by ZutaCore instead of being cooled by air like most of the data centers today, you're actually saving 40 to 50% of your CapEx because of size of data center and because of less equipment on chillers and other that you need in a solution like that.
Thank you.
Do we have?
How does this fit into the? So if I'm a hyperscaler, how does this fit into my current strategy of deploying the servers or the data centers I want to do? How do you fit there?
Okay, so ZutaCore is working directly with the ODMs, mainly in Taiwan, but the ODMs will supply the servers or the full racks already equipped with the ZutaCore solution to the hyperscalers. That's where we work. And the infrastructure providers will provide all the rest of the components needed in the infrastructure itself. So we are working with the providers in infrastructure like Munters, like Mitsubishi Heavy Industry, that will provide the infrastructure, and with the server manufacturer, the ODMs, that will provide all the components in the servers with all the warranty needed and fully tested.
Thank you for your presentation. Can you elaborate a little more the differentiator with the other liquid cooling to chip solution? You mentioned about your solution saves chillers and so on. Can you elaborate a little bit more the differentiator compared with other solutions?
Yes, this was a quick nutshell kind of presentation, but when you compare it to other cooling solutions, there's two main advantages, and I'm talking about other kind of cold plates. One is on the flow. The flow of single phase needs to be a minimum of 1.5 liter per minute for every 1,000 watts. The new chips coming in 26 will be 2,000 watt per chip, meaning you need to flow in 3 liters per minute. That's one point of this equation. The other point is what is the temperature of the facility water you need to use for getting the chips in the temperature they need to be. And in ZutaCore, the advantage is about 10 degrees higher in the facility water, meaning that instead of chillers and instead of evaporating water for cooling, you can use dry coolers in the majority areas of the world, most of the year long, and that will be saving a lot of energy, can come to 40, even 50% of energy in data centers by that alone.
Thank you for the presentation. Really quick, just the reliability of the system, and have you got demonstrated records of that?
Well, this company started installing in data centers in the US since 2019. The system's working in Equinix since, so this is a place to figure out the reliability. And others that are working for 3 and 4 years also in, say, in Europe, like in France and in Holland. But the thing is that the reliability is very high compared to other systems because we're not putting any water in the system. There is no corrosion, there's no biological growth. The liquid stays for years and years. I mean, probably much longer than we will stay, and the servers will stay here, and nothing happens to it. And the reliability is that there is almost no maintenance needed in the system like this for 5 to 6 years long.
Thank you.
Okay, so you showed that you need to have two-phase liquid cooling for, when we go to the 10 kilowatt server units. But today, most of the data center, the racks are maybe a couple of kilowatts. I mean, the big ones, of course, goes to 10 kilowatts. So my question is it also an efficient technology from a TCO perspective if you have like a 1 or 2 kilowatt server racks, or is it only, the business case is only for the high-end type of servers?
Well, when you have servers that are 1 to 5 kilowatts per rack and you're okay with air, I wouldn't bother. But when you're trying to go for 20 kilowatts or 50 or today even 120 kilowatts per rack, then you would need to go to direct-on-chip liquid cooling. And when your chips are moving up from 1,000 watt per chip to about 2,000 watt per chip, you will need to move also from single phase to two phase. So we're looking at the future and future proof of the chip that fit the chips in the industry. And that's where our major look is with the data center industry. We're less looking at the existing data centers with low power CPUs because then, as you said, it is less efficient or is not worthwhile changing from what is existing today. Lucky for us, there is such a huge construction of AI factories at the moment that the future is very, very near.
Thank you. Thank you, Shahar. Next up, we have machine vision.
Morning, everybody. Great. So, I've got some bad news. Railway maintenance is in crisis. We spent £100 billion last year keeping our existing infrastructure both safe and reliable. And that cost is growing, both because of increased volume of traffic, but also because of climate change. It's highly manual, 25% of the cost is people, it's dangerous, and we can't get young people into the industry. So what are we going to do in the future? So at Machines with Vision, we enable maintenance workers, whether that's a person or an autonomous vehicle, to navigate safely and precisely to any fault found on the track to carry out their maintenance work. So in the past, maintenance was highly manual and very inefficient. Today, we're providing digital navigation tools to on-track workers to get to the precise fault of the precise location of a fault found by inspection data. And that exact same technology is very soon going to be automating machines to go to faults on track. So let me explain how our solution works. We've got two parts. We've got Fault Mapper, which is a camera system that's fitted to the underside of an infrastructure inspection train. That might be a dedicated train, or it could be a passenger service collecting inspection data. From that camera data, we build an accurate, centimeter accurate image-based map of the railway. And from any picture of the railway, we know exactly where you are within 30 millimeters. That's integrated with the measurement system, so we can map all of that measurement data down to 30 mil. The second part of our solution is Fault Navigator, which is a mobile application running on either a mobile phone or a tablet, which is used by track engineers out on track to visually see through an augmented reality interface the faults at the exact location they were detected by the inspection fleets. So let me show you what that looks like. So this isn't a trial, this is being used operationally in the UK today for ultrasonic defect inspection. So you'll see a short video here. So this track engineer has scanned the track already. You might have seen an arrow. It's told them which direction they need to move to find the fault. They'll rescan the track as they get close to the vicinity of the fault. And then there you go. So they can see exactly where. So those two pins are the two probes on the ultrasonic train where it picks up the defect. They can then take out their specialist equipment. In this case, it's an ultrasonic walking stick. They can check the fault and instantly know whether this is a serious enough fault that it requires a piece of maintenance work, or whether it can essentially be checked maybe in a year's time. There's a huge efficiency out on track, but the really important thing is there's a black hole at the moment between connecting what happens on track to the asset information stored digitally. This closes that loop. So we think we can save the maintenance industry £40 billion per year. That's our ambitious goal. And our business model lets us collect 10% of that value. So we believe this is a really big problem to solve, and we've got a great solution for it. The industry is in crisis. It needs new solutions. Getting people to do this job in the long term is not going to be possible. 1 billion people traveled by train last year. They're paying for this, and they're still being disrupted by poor and failing infrastructure. So we believe we've got a strong potential to build a strong customer base. We're solving a high value problem. It's really easily installed into existing processes. It's very visible. Our end users love the solution, and it's been deployed with Network Rail since 2022. We're now trialing in the US and in the rest of Europe. It's highly innovative, high technology innovation, but innovation around the business model. I'm going to move fast through this quickly. It's really easy to get deployed, fits into your processes. We've shown that for every £1 you spend, you get £10 back. That's either a direct saving or resources you can put elsewhere into your business. And we've got a clear roadmap from enhancing manual inspection to full automation of maintenance. And cost and reliability are the two factors that stop people using trains. We need more people on trains to get more, reduce CO2 emissions and get less road congestion. So just about us, we're based in the UK, in Edinburgh in Scotland. We've been founded in 2016. We've raised £5 million of venture capital. We've been operational in the UK since 2022, and we're trialing in other parts of the world as now. And I think the headline on this is, we're going to transform how railway maintenance is done in the future, saving a huge amount of money from the business, making railways more reliable, getting people onto track, and reducing CO2. Thank you.
Thank you. Now we'll have your mentor, Roald, say a few words.
Yes, this is Roald Lengo again from Hitachi Rail Genova. So Machines with Vision has some very innovative and minimalistic solution for high accurate localization of rail and infrastructure defects along the line, overpassing common problems related to GNSS technology and similar. This sounds trivial, but is what railway infrastructure managers are searching for in order to optimize maintenance costs and increase their rail safety and infrastructure safety in general. Inside Hitachi Rail, there are colleagues that are really enthusiastic on starting to collaborate on these aspects to improve our products and to make them more appealing. So this is a very interesting and minimalistic solution that I think everybody is looking for in this moment.
Thank you.
Thank you.
And now for our Q&A, do we have a first question?
Thank you. Thanks for the presentation. I fully agree. We need more people on trains. That's a great point to make from a rail person. I think challenge. We don't want more people on track. However, so one of the solutions here provided is around sort of giving people tools on track to navigate and find fault and repair, etc. You said there's a roadmap towards automation. Can you describe that a little bit more?
Yeah. So the exact technology that's used when that mobile app can go onto a vehicle and can navigate to the fault initially in a supervised mode, so that like a person in that vehicle will carry out the actual maintenance work. So for example, with a North American partner, we're developing a tie replacement vehicle. So it navigates to the right tie, and then a supervisor then does the change of the tie. We're developing the next stage of that, which is the full automation of that tie replacement. So that roadmap's quite short. So we'll have demonstrators in 2026 of doing on-track automation of maintenance.
Well, thank you very much for a fantastic solution. My question is very simple. How is the business model look like? How do you get money from your customer, or who is your customer?
Yes, our customers are the infrastructure managers, so the actual railway owners, but also their tier one suppliers who are carrying out maintenance work or inspection work. In terms of the business model, it's really, really simple. So we don't sell equipment, we lease equipment. We're also talking about partnerships for ingesting camera data from existing systems like that, PLPR, for example. We then lease the app and the platform on a monthly basis based on volume of use. So it's a software as a service model.
How do you price it?
So we look at the business case. So for example, with Network Rail, I can say that the business case for optimizing ultrasonic verifications is 50 million pounds within Network Rail. So we look to capture about 10% of the value that's delivered to our customer. That's our sort of approach. So we negotiate it on a value basis, not on a this is a set price on a page.
Okay, got it. Thanks.
Okay.
Thank you very much for your great presentation. So my question is also simple. So I couldn't really understand how your solution differentiate from other camera-based inspection systems. So could you elaborate this more?
It's a great question for me because we don't do inspection. So this is the problem. This is the heart of the problem. There used to be one discipline called inspection and maintenance, and then we've had so it was done. Trains would stop and fix. We've had 30 years of innovation in inspection, but we've created a problem downstream for the actual maintenance work. There was an assumption that GNSS would effectively link the two things together. It doesn't. That assumption isn't true, particularly in the railway. So it's created all sorts of problems. So where we sit is in bridging between the inspection and the actual work done out on track. And our long-term view is that railways will be self-healing. So the inspection and the maintenance will be fully automated. And we're building the platform that's going to be the start of that journey.
So your solution is more about geolocalizations.
Yeah, so we've got the world's most accurate positioning system for railways, but that's a very hard thing to sell. So we're building solutions on top of that, which actually solve immediate problems in the railway. and we found lots of customers that have those problems.
Thank you. So maybe two questions. One relates maybe to what Jim was asking at the beginning is, what is the value for the client? Is it less workers or more efficient workers?
Yeah, so Network Rail aren't going to get rid of track engineers for the next 5 to 10 years. So it's about reallocating those resources more usefully. So in the case of like ultrasonics, sometimes an ultrasonic fault is visited 70 times. It's the same fault. To go back to it 70 times, think about the cost of that and the resource allocation. Why does that happen? Because a lot of people know that's the same fault. I'm sure that's the same fault we went to 6 weeks ago. They don't have the audit trail so that they can change the standard to say you have to go out to every suspect every time it's measured. This solves that problem. Although it's an operational tool, it's actually a data tool. So it lets you link on-track activity to your data source so you can work more efficiently and go, right, we saw that data on our last measurement. We know what it is because we've been on track, we've investigated it. We know we went to the right place. So now I can decide not to go and do that verification, maybe for 6 months or a year. That's the real value proposition to the customer. Network Rail go out to ultrasonic faults 60,000 times a year.
Okay. Second question is, can you, I mean, more technical, can you associate it to like general consumer map tools like Google Maps, Apple Maps, whatsoever? So what I'm trying to say is like, are you one level down those kind of general application and you could associate to it? So that's, or is it like a standalone apps that
you could think of us as like the Tesla for autonomous maintenance machines. So we want to build the platform. Well, maybe that's a bad example because Tesla make the cars as well. Maybe think of us as Bosch, who've just bought 5AI, or some of the other technology platform companies. So we want to be the software platform that uses computer vision, AI, and robotics to navigate and automate all maintenance tasks on track. And we have the team to go and do that thing.
25 seconds. So not inspection, not predictive, doesn't tell the client, you know, that in 3 months' time this is going to.
That's where we start. That's where we started.
Okay, you flip that to this is inefficient in terms of how you maintain your asset.
Yeah.
And we're going to help you understand the amount of time and use that in order to be more efficient with your maintenance approach. Correct?
That optimize the maintenance, because at the end of the day, inspection is all about how do we maintain the railway better, and there's not a lot of innovation in that area at the moment.
Okay, thank you.
Great, thanks.
And now we have our final clip by Gyro.
Hello, I'll just get the clicker. And Ronan, you might do that for me. I'm old school, I've got paper, so apologies. So data center and energy industries are deeply interdependent. Gyro is focused on sector coupling these critical industries to accelerate the transition to a fully renewable grid. We're focused on 3 key themes. Is it, Ronan, just pop onto the next slide there. We're nearly there. Yeah, so 3 key themes. We're focused on real-time industrial decarbonization, focused on data centers as an industrial scale distributed energy resource to accelerate the energy transition, and to convince communities that are hosting this infrastructure that data centers can be a catalyst for sustainable economic growth. So we need to build digital infrastructure that complements and accelerates the energy transition. So the market demand for digital services is growing exponentially. The grid is struggling to keep up with demand while it transitions to a fully renewable grid. We believe data centers should be active grid participants adapting to the availability of renewable energy rather than demanding continuous supply. So we focus on the hyperscalers' need for grid access and the need to meet sustainability targets. Secondly, we focus on grid operators that value that flexibility. And by targeting strategic locations where these needs intersect, we create an industrial campus model that blends digital infrastructure with energy resilience. This makes projects financeable whilst delivering clear benefits for the grid and for local communities. And at a platform level, it builds trust with communities, grid operators, and the tech companies to scale the solution internationally as a platform. So we've redesigned the infrastructure lineup with temporal response characteristics to support the data center and the grid simultaneously. Our hybrid analog digital approach delivers seamless power quality and stability, and this overcomes the limitations of inverter-based systems delivering instantaneous inertial response, enhancing fault tolerance, and providing real and reactive power regulation. These are capabilities that will be indispensable in a 100% renewable grid. So the system dynamically adjusts based on the availability of renewables and system demand. When the renewables are abundant, we act as a large flexible consumer. During moderate conditions, we provide demand response. And at elevated demand, we support the grid as a generator while becoming a vigorous competitor of conventional thermal plants that need to be displaced on the system. So this ensures that our industrial fleet can accelerate the energy transition without burdening the ratepayer. So without time for a detailed review, the key takeaway here is that the setup is designed for medium voltage and for resilience and scalability. So this isolated parallel ring configuration allows seamless expansion and load distribution. This hot swap approach ensures data centers can grow with the demand and adapt to evolving IT loads without invalidating the original commissioning. A sophisticated multi-layer control system ensures seamless integration between the grid, the data center, and the energy markets. So our solution combines sector coupling, real-time flexibility, and system-wide efficiency in a way that traditional approaches don't. By integrating digital infrastructure with market operations, we unlock new revenue streams while enhancing grid stability. At the core of our model is real-time decarbonization, avoiding emissions or emissions-intensive grid imports. So this not only decarbonizes the data center's operations, but also drives emissions reduction in the broader grid, as can be seen below the line. So it's a systematic innovation that requires a new business model. The business model is anchored by very attractive real estate lease returns, making it institutionally investable. And the energy services company removes the operational complexity and allows the data center customer to concentrate on IT. The higher capex cost of enhanced energy systems is offset by capturing energy market earnings that conventional data centers are leaving on the table. Hitachi and Gyrogy are both working to solve the same problem, but from different perspectives. There is an opportunity to create a new category of flexible zero carbon infrastructure to displace conventional generation. And given the scale of the data center market, this could be transformational. So beyond technology and business, this is about driving real change and how digital infrastructure supports communities and the wider energy system. And I thought I'd leave this slide here in case I need it for questions later. This innovation challenge has highlighted for us how aligned we are with Hitachi's mission. Reshaping business models and technology applications can redefine how data center and energy industries operate. We believe this is a transformative opportunity for profound impact at scale for Hitachi's energy products and services. So to show this in action, we're developing an industrial campus in Ireland, repurposing an old site with an exceptional energy and water infrastructure base. This site integrates onshore renewables, offshore wind, and interconnection capacity, making it an ideal proving ground for a scalable zero carbon data center model. This project, you can move on there, Ronan. This project doesn't just power data centers, it reimagines how energy and digital infrastructure work together for the benefit of businesses, communities, and the planet. And we'd love to explore how Hitachi and Gyrogy can collaborate to bring this vision to scale. Thank you.
Thank you. We now have a word from your mentor online, Cormac Tennant.
Great, thank you. So having spoken with the Gyrogy team alongside Alexander Grubik, it's clear that they have identified major challenges within the data center industry, getting available power from utilities and also being a contributor to the community. The solution is not only innovative, but well developed, enabling ancillary services that generate revenue while actively supporting the grid. What's actually impressed myself and Alex is how well Colin and the wider team understand the segment's complex requirements and have designed a complex value proposition that directly addresses them. It's an ambitious solution that requires collaboration across multiple stakeholders, which fits very much in alignment with Hitachi's way of working. Gyrogy has also identified and is already engaging with key partners to realize this. Their innovation is not only theoretical, they also have the mentioned pilot project in place, proving real-world viability of their approach. And importantly, their solution is highly feasible as it integrates proven technologies in a new and effective way. Lastly, Gyrogy is tackling a critical industry challenge with intelligence, innovation, and ambition. And myself and Alex Grabik believe that they have what it takes to make a real industry impact in partnership with Hitachi. Thanks.
Thank you. We'll now start with the Q&A if we have a first question.
So thank you very much for your presentation. I think it is a very important topic, but if we look at your company itself, as you grow, maybe your assets for the leasing service will be continuously grow. How do you manage your balance sheet in such kind of a journey?
So I think Gyrogy's role is really to bring big partners together. There's no one big company. Even the biggest companies like Hitachi cannot take on the entire breadth of the complexity of the energy challenge for hyperscale data centers. So our role as Gyrogy is to get that business model and technology platform, and then a full partnership model with energy utility companies, renewable energy developers, equipment and service providers such as Hitachi, as well as the data center customer. So it's really about creating a platform. If you like, it takes a village to really get the levels of decarbonization that's going to be required here. And I think once it's proven, those partners can move on together and deliver more sites, both in new projects, but also go back and retrofit existing fixed demand data centers to be more flexible and to offer those services and give them a longer lifetime. So it's really a partnership model, and Gyrogy, are a technology partner to that in lots of ways, but I suppose also the glue to bring bigger partners together, such as institutional investors and so on.
So if I understand correctly, you may have multiple options to get the revenue from the varieties of ecosystem. Do you have any the clear plan to make the multiple channels to get the revenue? For example, if you look at the digital side, leveraging the flexibility service or decarbonization opportunity, you can get into the more the flexibility, the market, or some kind of the carbon credit potentially, some kind of things.
Yeah, so I probably differentiate two revenue streams. One is the traditional lease real estate model with hyperscale data centers that really funds the capex and de-risks the project. And what we've done is we've sanitized that investment by taking all the risk out of that and carrying all the risk into an energy services company, which works in partnership with utilities and renewable developers, PPAs, etc., to take all that energy complexity and deliver, fully reliant green power over 2 medium voltage cables over the fence to the data center customer, who can then just concentrate on what he does. There's a lot of complexity in looking at energy in real time that needs to be dealt with. So kind of there's two business models. One is lease, standard real estate leasing, and the other side is an energy services company that's a full service and that bear the SLA and uptime and resilience and everything of the data center.
Thank
you. You went quickly through the technical solution. If I understood well, your idea is to have the data center with the fully backup power with the flywheels rotary machine, and using this backup power for ancillary service to the grid, or can you elaborate a little bit more the technical solution?
Yes, so maybe Ben in the first presentation mentioned about data centers having to build a power station. So we advocate to build a different type, a much more faster and more agile power station, for want of a better word. So we've taken the traditional backup energy assets, we're putting in front of house as a grid facing, not conventional, but distributed energy power station that will compete against the centralized plants. So it will effectively be making a make or buy decision on energy. It either buys from the grid when it's renewable, or it makes it itself. Okay. The data center then sits behind that energy plant. Okay. And you're right, we've integrated, obviously digital is huge, but one of the big challenges in power systems is having some analog and having some inertia in the system. So we've I suppose carefully picked different technologies that work on different timeframes that can support a resilient power system for the grid and for the data center simultaneously.
Okay.
On the let's say the spectrum of business model you have presented, how much did you test? Did you test it in market? Like, do you have some use cases, some deals you have done, and got feedback and learn from it? What is your learning with clients on real cases?
My own experience before founding this company was, developing hyperscale data centers for the big hyperscalers, and recognize that in order to scale, we need to address the grid in a very different way. So I suppose that's where the background is coming from. In terms of proof points, this project that I showed you on the screen there, we have our institutional funding partner on board that's fully invested in running that project through the consenting phase at the moment. We have a utility company on board. We have a biomethane supplier to help us to decarbonize the fuel system on the engine side of things. And yeah, so we're gathering those big partners together. And it is a partnership model. And maybe back to your question, it's actually the fund structure in terms of taking the overall investment life cycle through the development phase, through financial close, through commissioning and on into operations. That fund structure allows different partners to enter and exit the investment at various different phases through the life cycle. So I suppose first project is going through consenting at the moment. It's going through the planning process and getting its power consents. And in terms of our a big part of this challenge for data centers is actually getting access to the grid. We are probably one of the only successful companies in Ireland to get actually a grid connection for a data center under this mode of operation. In the last number of years, it's highly curtailed. So we present a huge amount of our work is actually working with the regulators and working with the policymakers to show that fixed demand data centers really can't have no place in the future, and that flexible demand is required. There's new policy after coming out only today from the Irish Commission for Regulation of Utilities that really recognises a lot of what we're doing here. So a big part of our job as Gyri is advocating for those policy changes that allows us as a society to build more data centres whilst providing benefit rather than curtailing the opportunity for everybody else. Thanks.
Thank you. So thank you everyone for your very exciting pitches. Thank you for the judges for taking the time to listen, follow up on questions, and see what the potential is here for both Hitachi and all our startups. So now we'll take short break of 20 minutes. During this break for the startups and mentors, the judges will be in deliberation so that we decide on the 3 winners of this final event. So we will resume in 20 minutes if everyone can make sure to be here on time. And yeah, good luck for the startups.
And then now in the kitchen area for the catering is preparing for the lunch. So please do not eat, like starting it. Please wait for the lunchtime.
When love comes in, ooh la la la. Love comes in, ooh la la la.
So please sit, have a seat, and then we will announce the winners.
Yeah. Yes. Our judges are missing. Okay. Okay, welcome back, everyone. We hope you had an exciting day. It was very interesting to see all these solutions. The deliberation was very hard. I can reassure you that we had to really discuss the top three because the competition was very fierce. But after a very detailed discussion, our jury were, of course, able to come up with our top three for today. So maybe we can have a drum roll. So the winners are drum roll. Strong Compute, ZutaCore, and Anilog. Congratulations. So congrats. It's actually funny that the three winners are actually online, the only three startups joining us online, but we are all here for you to support you. So congrats. And congrats to all the other finalists also for being here today and for pitching in front of top people from Hitachi. So congrats again. It's a very big achievement. You've come very far from more than 200 solutions to today. So congrats also to everyone. Maybe now we can also hear from our winners online. Maybe we can start with Strong Compute. If you can have like a winning speech for us.
Oh, good day, everybody. Adam Peaston here, engineer and data scientist at Strong Compute, staying in for intrepid CEO and founder Ben Sand, who's had to jump on a flight, unfortunately. So he'll be several miles above the Atlantic Ocean at the moment, but I'm sure that he sends his sincere thanks and congratulations to the other winners. We're extremely proud and pleased and honored to have been recognized in this way by Hitachi, and we look forward to chatting more with Hitachi about how we can supply them with the compute that they need, support the move towards a renewable and green grid, and a release from the requirement to have power stations right nearby all of your data centers. Congratulations to the other winners again, and thank you so much for everybody.
Thank you.
Thank you indeed.
Now ZutaCore.
Hi, it is my privilege and thank you very much for this. And we're looking forward very much to work with Hitachi and see how together we can make the AI industry much more sustainable and good for the world, not only from the IT side, but also from the environment side.
Thank you. Congrats. And finally, a word from Anilog.
Yeah, really appreciate it. Thank you very much. We're really, really excited and want to thank you. I want to say also a special thanks to Christine. I mean, in this case, I think there is a big part of the mentoring and bringing the opportunity the way she brought it to us. And so thank you, Christine, and thank you, Itachi, for this amazing opportunity. We are really excited and very happy to be part of the program and looking forward to the next steps with you.
Thank you. Congratulations again. So we are now coming to an end of our final event. So I would like to invite Kenichi Funaki for our closing remarks.
Okay, thank you very much. I believe that everyone enjoyed this event as a whole. And although we selected the top startups, but again, the finalist here is the deserved co-working with Hitachi. And also we are really excited about what you talk about, and also a potential opportunity to for the further collaboration. So please do not hesitate to keep communication with any kind of Hitachi entities as well. So if you look at these Agorize events, every time we see fantastic ideas, and then we get a lot of insights and stimulated by what Hitachi doesn't know. So I think that from a corporate venturing office perspective, this kind of event is a very, very important platform for Hitachi to understand what is going on outside Hitachi, and what is a cutting edge potential opportunity for the future. So please continue the joining this kind of events when we have, and also this is a precious moment for us to be connected with each other, so to keep this network, and then carry any kind of ideas and insights back into your office as well. So finally, thank you very much for your strong support every time. And we really enjoy the collaboration with Agorize. And then if I understand correctly, the Paris itself is a next emerging startup ecosystem. The Actually, the Japan is watching what is happening in Paris, because we are searching for the potential opportunity to be the one of the big startup ecosystem in the world. So let's go along with together. Just for your information, in Tokyo, we will hold Tokyo Metropolitan Government will hold a big startup the ecosystem event called Sushi Tech. It is like a Vivatech in Paris. Actually, sushi doesn't mean the food itself. The sustainability, high tech, something like that. But anyway, if you have a chance, please come by to the Tokyo and enjoy the startup ecosystem in Tokyo. Thank you very much, and I hope that it is a great help for you. And then the afternoon session will continue after lunch. Please enjoy the lunch, and then let's get back to the afternoon session. Thank you very much.
Thank you so much. Great. So thanks a lot, everyone. Again, startups, mentors, judges. It was a very okay. We can just keep it. If it was yes, this is the one. So yes, I was thanking everyone for being here today. It was a real pleasure to have everyone here collaborate around how we want to drive sustainability in tech every day with Hitachi, with you leading startups. So thanks a lot for being here today, and we cannot wait to see what you implement with Hitachi and outside. So thank you, and congrats everyone again.
Thank you.
So thank you for joining this event. And from now, we will have finally lunch. So please go to the kitchen, startups, Agorize members, and the Hitachi members. Let's talk together and enjoy the lunchtime. So thank you. And then, sorry. For Hitachi members, please come back here 1:30 sharp. Sharp.